Hello and welcome. My name is Nick, and today we are looking at some AP Maths and we're looking at absolute value graphs. So what I'm going to do now is I'm going to show you how to draw an absolute value graph intuitively, and then I'm going to show you algebraically as well. So the first thing we want to do is look at an absolute value graph, the regular one. So we know that a normal graph, y equals x, goes like this. Okay, it would go straight through. But an absolute value graph, because if x was -1, the absolute value of -1 is +1. Because when we have the absolute value of a number, we're only interested in the number, not the sign in front. It's always positive. So -1 would actually, y would end up being +1. So this is our absolute value graph, the regular one. And if you know that, then you can look at the other types of absolute value graphs that you're given, and you can work out what they're going to look like. So first of all, this is the general equation. We have y equals a, which tells you the slope, and then p will tell us if it's shifted left or right, and q up and down. So negative absolute value just simply says that the slope goes downwards. So it's in the opposite direction. And so intuitively, if I put in -1 here, the absolute value of -1 is 1. And so I'd get a negative value. And the absolute value of 1 is 1. And then it would be -1. So that they would always be negative. Because this is always positive, and because it's a negative outside, they're always negative. So this is y equals negative absolute value x. And if this was a 2 here, we've just got it steeper. So this might be y equals 2 absolute value x. Now let's look at +3. Well, +3 is going to shift the value to the right, to the left, because positive shifts it backwards. So it's simply going to shift this regular graph backwards to -3. Now, if I was to do it algebraically to find the y-intercept, I make x 0, y equals, and then it would be 3. And so then we would get this y-intercept of 3. We're going to do it algebraically in a second. So the positive shifted backwards. If I was to find the x-intercept, I would make y equals 0, and so I'd have absolute value, which we would drop, and then the 3 would go to the other side and become -3. The +2 absolute value simply shifts it up by 2, and so it goes up by 2. So let's look at how we are going to do, how we might have done this algebraically. So if we if we make x equals 0, we have 0, so y equals 2, and then we have the y-intercept. Now to find our x-intercepts, let's just look what happens. We make x-intercept, we make y equals 0. So we have 0 equals the absolute value of x plus 2. When this goes across, it becomes -2. And an absolute value can never be negative because it's always a positive number. So this is no solution. So we get no x-intercepts, which is what we have here. So that's going to bring me on to now doing them algebraically. Okay, so now I'm going to do these graphs with algebraically. I'm going to graph them algebraically, getting the y-intercept, the salient point, and the x-intercepts if possible. So let's first look at the y-intercept of this graph. Well, if I make x equal 0, I get 2. And so the y-intercept is 2. Okay, let me just make that, just say y-intercept there. And if I want to find the x-intercept, I make y equals 0. So this is basically, let's say, the x-intercept. I make y equals 0, and I get 2 root x plus 2. And if I go across, I get negative 2. And an absolute value can never be negative, so there's no x-intercepts. So this is why we get the salient point is actually more important with most of these. Now, the salient point tells us where it shifts upwards and to the left. So our salient point is basically equal to P and Q. So let's look at our salient point. Here, our P, there's no P because it's plus 0 inside the root value. So our salient point is 0. And our Q is 2. And so our salient point is also happens to be our y-intercept. And so our salient point is over there, as is our y-intercept. And it goes up twice because twice as steep as this. And I like to put in the absolute value, the regular one, so we can compare it. And so it's going to go up much steeper. Okay, and so this point here is 0 and 2, which also happens to be our salient point. So our salient point is the point of our V. Now, with this one, because we don't have any x-intercepts, we would maybe want one other point on the graph. So we could simply just substitute in 1 here, and then we'd have 2, and 1 would be 2 plus 2 times 1 is 2. And so we'd have 1 and 4. So we could maybe put there 1 and 4. And so this point here would be 1 and 4. Now, if we made this negative 1, it would be the absolute value of negative 1, which is plus 1. So 2 plus 2 is 4. And so we also have it mirroring negative 1 and 4. So this point here is negative 1 and 4. Okay, now let's look at the green graph. So we want the y-intercept, and that's where x is equal to 0. So we get y equals 0 plus 2 is 2. So again, the same intercept. Let's look at the x-intercepts now. So we make y equals 0. So 0 equals negative plus 2, the absolute value. Now the absolute value can come over. And so it becomes positive. And now we can say that yes, that it does exist. The x-intercepts do exist in this case. Because say we had x as plus, so it was plus x, it would still become 2. So plus x is 2 and minus x is also 2. So if this value was negative 2, we would still get a 2. And so we look and we see that there's 2 and 2 here, minus 2 and 2. So basically what I'm saying is we can say that this is, so plus or minus x is equal to 2. So x can be 2 or x can be minus 2. And so it's looking like this. with our salient point. Now our salient point is going to be, remember, it's P. There's nothing with the P, so it's 0. And make it 0, and it's 2 again. And so that was our salient point there at 0 and 2. Same as before. Same as the pink graph. So we see both absolute value graphs shifted up by 2. So we had the same salient point y value, and it was P was 0 in both of them. Now let's look at the yellow graph. So what we've got is, let's find the y-intercept. So we make x equal to 0, and so we get y equals 0 plus 2. And so the absolute value of plus 2 is just still 2. And so we get plus 1, so the y-intercept is 3. So the y-intercept here would be up here. 1, 2, 3. Now let's look at the x-intercepts. Well, we'd have plus 2, negative 1, no intercepts, because we cannot get, the absolute value can never be negative. So none. Okay, but now we can find a salient point. And so we look at the P. Well, the P value is, and so, now remember that it's negative P. So the P value here is negative 2. Because remember, a positive shifts it backwards. So this is negative 2. We must remember to change the sign of this for our salient point. And then our Q is the 1. So our salient point is negative 2. And we go up to 1 here. Let's do it in it's yellow. So it's negative 2 and 1 is our salient point. And our y-intercept is 3. And so we can go up like that. And it's going to run parallel with our y equals with our white one, because it has the same a, so it's got the same gradient. So there's our salient point, and there's our y-intercept for the yellow graph. So hopefully that helps you to draw absolute value graphs. You are not always going to get an x-intercept, remember that, because you cannot get, if you get a negative value, an absolute value can never be negative. You're always going to get a salient point, and that's going to be based on the Q. So Q shifts it up and down, the salient point, and P, a positive value for the P shifts it backwards along the graph, and a negative value of the P shifts the salient point forward. And you are usually going to get a y-intercept, almost always. So hopefully that helped. If it did, please find the subscribe button somewhere on your screen and like the video and share with your friends and all that good stuff. And I will see you in the next lesson.